Hey guys, today we're going to talk about limiting reagents. Reactions don't usually occur in exact stoichiometric amounts, or the proportions indicated by the balanced chemical equation. Usually there's an excess of one reagent, and some of this reagent will be left over after the reaction. The reaction used up first in a reaction is called the limiting reactant or limiting reagent. This is because the maximum amount of product formed depends on the amount of this reactant. When it is used up, no more products can be formed. It therefore limits the reaction. Excess reagents are therefore then the reactants present in quantities greater than necessary to react with the amount of the limiting reagent present. So this concept is similar to prom. If there are 26 awkward teenage boys and 20 awkward teenage girls, only 20 awkward prom dates can be paired. Girls are therefore the limiting reagent, and they limit the number of boys that will have dates. There is an excess of boys. So what are the implications? We need to know which reactant is limiting in order to predict correct reaction yield. So we're going to use this reaction as an example. Nitrogen reacts with hydrogen to form ammonia. 3 grams of nitrogen react with 3 grams of hydrogen. We want to know what's the maximum amount of ammonia we can have from these two reactants. First, we must decide which reactant is the limiting reagent, and one way to determine this is to calculate the amount of moles of product that can be formed from either of the reactants. The limiting reaction will yield the smallest amount of product. So we start with 3 grams of nitrogen and 3 grams of hydrogen, and from each of these we determine how much ammonia we can get. So we start with nitrogen, 3 grams of nitrogen, we turn it to moles of nitrogen, and then finally convert it to moles of ammonia, and we get a total of 0.2 moles of ammonia from 3 grams of nitrogen. And we do the same thing from the 3 grams of hydrogen. 3 grams of hydrogen times 1 mole of hydrogen over to molar mass, and we get 1 times the stoichiometric coefficients, and we get 1 mole of ammonia from that. So what we see is that nitrogen can produce less ammonia than hydrogen. So nitrogen is therefore the limiting reagent, and 0.2 moles of NH3 is the correct theoretical yield of the reaction. So another way to determine which reactant is limiting is to convert all reactants to moles and compare the ratio to the stoichiometric equivalent. So what we're going to do is convert both of reactants to moles. That's what I've done here. Nitrogen, 3 grams of nitrogen is equal to 0.1071 moles of nitrogen, and 3 grams of hydrogen is equal to 1.488 moles of hydrogen. We then want to normalize them so we can compare them. So we divide by the smallest amount of moles, so we get 1 mole of nitrogen for every 13.9 moles of hydrogen. We then want to compare it to the chemical reactions coefficients, and we see for every 1 mole of nitrogen there should be only 3 moles of hydrogen. So there's therefore an excess of hydrogen, which means nitrogen is the limiting reagent and hydrogen is the excess reagent. And then after that, all we have to do is carry on with our calculation from using the limiting reagent, which is nitrogen. So a little mental map of what we just did is we converted both reactants to moles. We then normalized right here, so we can kind of compare it to the stoichiometric coefficients. And a good way to do it is, in this case we normalized and made nitrogen 1, which is the same as in the chemical reaction. That doesn't occur every time, so if we don't, we can just multiply a whole number to get the same thing. We then compared it to the stoichiometric coefficients right here, and we determined the limiting reagent, which is nitrogen. So what are the implications of limiting reagents? Well, chemists usually choose the most expensive chemical in the chemical reaction to be a limiting reagent because they want to use most or all of it and convert it to product, because they want to convert all their expensive product to our reactant to product, and they can use up as many of the cheap stuff as they need. They allow the cheaper reactants to be present in excess. So that's pretty much a quick little introduction to limiting reagents. Thanks.